All right. Hello, everyone, and welcome to our online learning experience. My name is Dana, and I'm a member of the education department here at the Aquarium of the Pacific. I believe last week, my friend Sarah was teaching. I know throughout the weeks, if you've been joining, we've had a lot of other instructors joining us. But today, you're going to have me, and we're going to learn all about our oceans and climate change. And we're going to do it in a really, really cool way today. So the way this program's going to work is we're going to be exploring something that I like to call data sets, which I'll explain here in a moment. And then we're going to take about 7 or 8 minutes for that, and then a couple minutes for questions from you. So if you're watching, we have a way for you to send in our questions. We have that Google Doc I believe your teachers are working on with you. And then we'll take those questions into the studio and we'll get to answer them live right here in our online programming. So we're excited to have you all join us today. Thanks for tuning in, and let's get started. So to set some expectations of what we're going to do today, like I said, we're going to be exploring data sets. But what is that exactly? What is a data set? Well, a data set is a group of data that a scientist collected. And the way we're going to explore it today is we're actually taking that little set, all of that data that they collected, and then we're putting it into an image. So I'm going to put an image on the screen here, just a moment. And actually my friend Sarah is really going to be doing the work. She's going to put the image on the screen, and then we're going to see what we notice. So the first thing we're going to do is we're just going to explore this very simple data set. Remember, it's a collection of information that we're putting into an image for you. Let's go ahead and jump over there. Whoa. What is that exactly? What are we looking at in this picture? Let me grab my tool right over here. What are we looking at in this picture? Whoa, it just flipped upside down. So if you recognize this, some of you might be saying, oh, well, it's Earth, of course, right? But how did you know that? What about this told you it was Earth? And also, why is this a data set? Well, how do you think we got this image of Earth? Oftentimes, our images of Earth like this are made up of satellite images all stitched together. So each image would be a data point, and then the whole image stitched together is our set. So in here, you were right, we're looking at Earth. But how do we know that? What is this? Yes, that is the United States, right? We recognize that landmass. In fact, what is this part right over here? Yeah, everyone, that's California. Sarah's back there going, that's us. Yeah, so we're looking at a very familiar landmass, but let's think a little bit more about the colors. What are the colors telling us today? How did we know that this was the United States and this was land, as opposed to this spot or this spot? That's right, the colors. So the white represents what? What do you think that might be representing? I think a lot of people sometimes say snow, right? However, is there snow over in the tropical Pacific right now? Probably not, right? So this white that we're seeing right now is actually cloud cover. What about the blue? How do we know what that is? Yeah, so the blue is usually representing our oceans, right? Now we're actually going to spin. We're going to go for a journey here together. And oh my gosh, what's happening? Where'd the Earth go? That's right, everyone. It's nighttime, right? So you can actually see the sun right up over here. And so it's nighttime on one side of our Earth. And as we continue to rotate, the colors might change a little bit, but you can see the sun rise over here, right? And there we go. Although technically I think that was the sunset. All right, so let's get back to our landmass that we all recognize, right? So this is the United States. This is our ocean. This is California. We're learning right here today. Now I'm going to load a different data set, okay? And what that means is I'm going to put something else on this image, and I want you all to think about it and make some observations. Now the data set I'm loading is going to be right here. Tell me what you think you see. Ooh, there we go. It's going to look really different. Okay. Oh my. Now what happened to our blue ocean? What are we learning and what are we kind of recognizing right now? Do we still recognize this? Yeah. So this is still the United States. Ooh, there's some white up here that's actually a little bit different. This is not cloud cover anymore. What do you think that white might be? Yeah, that's snow, right? Or ice. But what I want to focus on right now is what happened to our water. Let's look at the Pacific Ocean. What do you think these different colors might mean? Okay. So what are some observations we can make? I notice that it's kind of red and yellow in the middle. And as you work up, it gets darker, right? It becomes more blue. What do you think that might mean? Share those observations, write them in there, write them on that Google Doc, and then we're going to chat about it. What about the other side? It's kind of the same, right? Kind of that brighter colors in the middle and working its way towards darker blue. Now, those colors are representing temperature. If you guess temperature, you are right. And so what does the red probably tell us? When we think of a red and temperature, yeah, we think hot, right? And so the red represents much warmer water. And as we work our way towards the poles of our Earth, you'll notice that the water gets cooler and cooler, okay? Now, ocean currents actually are really driven by temperature. You can kind of see, and you can also see, let's see. So like you can watch currents by focusing on the temperature. Look at the California coast. What's going on over here? Yeah, the blue starts to expand into our coastline here. In fact, California is what we call a temperate coastal area. And that means that the temperature of our waters fluctuate a lot. It's not tropical where it's like warm all the time, and it's not Arctic where it's cold all the time. But if you watch, we get a little bit of cold water, and then boom, we get a little bit of warm water coming up. So this is actually in June. Let's see, we're looking more. Yep, there we go. And then it's coming down. So you can kind of see the date. Oh, it's a little closed off up here. But you can see our temperature is drastically changing. Now, let's look at some other currents. What do you notice down here? Ooh, what's that? Where? Over there. Yeah, so that was kind of a little eddy, right? A little whirlpool. So our temperature in our ocean and our currents move around. And I want you to look at how it might affect our area. Like I said, so we zoom in. This is California. You see those temperature changes. Now, what about if we were to go down to the Gulf of Mexico? Does that look similar? No, not at all. So you can see it does fluctuate a little bit, but for the most part, it's staying in those warm colors. What about over here? So on our coast, cold water came down, right? But on this coast, what's happening? Yeah, the warm water is coming up. This is the Gulf Stream. Have you ever heard that word? So some of our main currents around the surface of our oceans actually have names. This is the Gulf Stream. It's warm water from the Gulf coming up along our coastline. Whereas this, whoa, too far. This is the California current. Cold water comes down our coastline, okay? Are there any other major transitions that you notice? What do you see? What's happening over in Europe over here? Yeah, so water, warm water is kind of working its way across, right? So what I want you to do for these next 2 or 3 minutes is I want you to think about those things that we've seen. In fact, I might even leave this on the screen here. I want you to make observations and ask your questions. I'm going to give you a minute or two to do that, and then we'll answer questions. It looks like we've already got a handful of them coming in. So take some observations, think through this. Our next topic is going to be climate and our ocean, okay? So let's go ahead and explore that. All right, my friends. So it looks like we have a lot of really great questions coming in. I'm going to answer them as we go. So our first question, Miss Hung wants to know, how does water affect the world and how much pollution is in the ocean? Well, that's a really hard one to answer. So water affects our world in so many ways. Just by looking at this current right here, you can actually see how water affects our coastline in particular. The currents on our surface are primarily moved by wind. However, there's also a great ocean conveyor belt, and I'll talk about that here in a moment, but it's a big mixing current that has to deal with overall temperatures, salinity, density, and all other chemical and physical factors that move water around our entire globe. Now, as far as how much pollution is in the ocean, that's also really hard to answer because of that ocean conveyor belt that I just mentioned. Pollution that might be coming from one area. For example, if we had pollution here we go. There we go. Coming from Los Angeles, it's not going to just stay in a pocket right here. You can see that the currents kind of move and it might expand and go other areas. And so to pinpoint where pollution is coming from and also to know where it is at any point is really hard. But there is a lot of pollution in our oceans. Now, Valerie wants to know, do turtles have tongues? Great question, Valerie. So they do not. Not like you and I have our tongue right here. Turtles instead have this really amazing thing called little papillae in their mouth, and they're kind of little pointy things that stop their food. When turtles eat, they eat a lot of water, swallow a lot of salt water, and then oftentimes they'll throw that back up, but they don't want all the food to come with it. So the little papillae actually keep it in their throat, and then just the water comes out. If you have the opportunity to Google a photo, I highly encourage it. It's pretty shocking. Now, Amber wants to know, why would water influence our climate? Isn't it global warming affecting our climate? Yes. So I want to say yes to all of that, right? So we're going to talk about how water is affecting our climate here in just a moment, because actually the ocean is kind of the driver of our Earth's climate. And I'll chat about that in just a moment, Amber. Great question. I'll try to cover it a lot in our next unit. Let's see. Mrs. Eva wants to know, how can we help the sea? That's a great question. We're actually going to kind of end with that one towards the very end of our program. But to preface that, I want you to try to answer that in these next 20 minutes or so. Based off what we learn and discover together, how can we help? Okay, so maybe we'll learn a little bit about where our action or how our actions are affecting the ocean, and then we can kind of talk about that at the end. Sophia wants to know, is the reason the ocean is warm is because of the sun radiation hitting it or reflecting on it? Great question. So let's take a look at, let me grab my tool. Let's take a look at this model right here. Where do we notice that most of the heat is coming from? Yeah, it's in the center, right? So that's in part due to the fact that that part of our Earth gets the most direct sun rays, and it warms the water right here. Then as you work towards the pole, a little bit less so. Now, Andrew wants to know, how do you get the data to color code the heat of the water? Great question, Andrew. It has to do with the fact that if you look at this scale down here, this is all technology, which is not my strong point, but we would put in data points and say, like, this temperature would be this color and this temperature would be this color, and then it creates this model, and then it takes those data points and makes an overall image, right? So just the way I said that satellite images of our Earth are stitched together to take one, we just plug the numbers in and the programming does it for us. Now, Sophia wants to know, is there an area that happens to be extremely warm that shows up black in the data? I'm curious. Oh, like down here? Really warm. Yeah, so take a look here at our scale, right? So if it's really, really cold, you can see ice becomes white. But when it's really, really hot, we fade in towards the black color. So that's where this darkness that shows up, there's some right there right now, right? Not the land, of course. But yeah, it's kind of a sliding scale. So that was a really great observation. So it looks like we have a couple more questions coming in. Friends, I do want to move on to our next unit here. And so we'll try to get we have one last question from Tanel, which is again about turtles and whether or not they're going extinct. And yeah, turtles are going extinct, and actually in part due to climate change. And so they are all endangered. There are 7 species of sea turtles on our Earth, all of which are endangered, and climate change is a big driving factor. So let's jump in towards learning a little bit more about how our oceans are affecting climate, okay? And to do that, we need to understand the overall movement of our waters, right? So right now we're just kind of looking at our surface temperatures, but let's take a look here. See if I can find it. Let's see. Sorry about this, friends. One moment. All right, so it doesn't look like it's there. One second. Go ahead and put a amber forest on. All right, friends, I'm looking for one that shows us, here we go, a little bit about this. See if I can pull that up and load it. All right. Sorry about that. Had to find the right data set. So this right here is more surface temperatures, but it's going to talk a little bit about our vegetation on land, which it doesn't actually look like it's showing up, but in here, you can see those eddies that I talked about, and these are a little bit more distinct currents. So before we were just looking at the overall temperature, right? Excuse me. Now we're looking at how the temperature actually plays into little currents. And so you can see the movement of the surface of the water. Surface currents are primarily driven by wind, okay? And then as we get deeper, like I said, and that's what I was trying to find for you, friends, was a deeper water model. But as we get deeper, our currents are driven by, let's see. Our currents are driven by changes in density, changes in salinity, changes in temperature of water. So I want you to think about this again. At the poles, you remember how cold the water got? Yeah, it got really, really cold. Well, cold water is typically more dense than warm water, meaning it's heavier, so it's going to kind of sink to the bottom. Then it's going to work its way towards the tropics, but what happens to water at the tropics? That's right, it warms up a little bit, and that water is going to warm up, and it's actually going to be reintroduced to the surface. And then it's going to flow through those surface currents that we just looked at. It might cool down again and sink. Does that kind of make sense? It's a whole current moving around our entire oceans. Now, just like our heart pumps blood and nutrients around our body, and it controls our temperature and all of the things going on inside, the ocean is like the heart of our earth. It's flowing our temperature around, it's moving water, and it's moving nutrients around our globe. So the question was, how is water impacting our climate? Well, it has to do with changes in pressure and temperature and how it affects our air. Now, another question was, how is it warming, right? So water has a very high specific heat. Now, what that means is it takes a lot to change the temperature of water. And however, land, like California, that can fluctuate heat really fast. So coastal areas like LA, for example, because we are so close to water, which takes a lot to change that temperature, that also, of course, plays a part with the air over the water. And that's air close to the water, which would be air over LA. And so as the temperature kind of in LA stays, or in the water stays more or less the same, it's going to maintain a nice cooler temperature over land. So let's go ahead and let's see our oceans and climate. So living near the ocean provides a little bit more of a kind of standard for our ocean or our land. And it can influence based on latitude, it can influence based on region, and of course, seasons. Now, what I want to look at is, let's see. Let me see if I can pull up a different data set here. One moment. So I want you to take a look at ice concentrations. Let's look at this. So we're going to hit play here. This is ice on top. So remember I mentioned that water up at our surface tends to cool a lot more? So you can see this, it's actually freezing, and then as it melts, it'll sink a little bit to the bottom, and that's kind of starting the rotation. All right. So currently, when it comes to how our temperatures and our oceans are all connected, right now, in order to have energy, to drive our cars, to run our houses, to run even our computers that we're using right now, we're burning fossil fuels. And that creates energy. It releases carbon dioxide into the atmosphere. And that atmosphere is basically acting like a heat trapping blanket. Now, what that means is it's getting warmer and warmer and warmer. Now, when I get cold, I put a blanket on, and then another maybe. But when I get hot again, what can I do? What can you do? Yeah, we can pull those blankets off. Now, the heat trapping blankets that we're putting around Earth by burning those fossil fuels are not easily removed. And so the Earth just keeps getting hotter and hotter and hotter. And that is causing, as you can see, our ice to melt and fluctuate. So right now we're back in 1993. Let's just play forward and see how our total ice surface changes. So 95 doesn't look like a whole lot of difference right now. We're in 96. 97. So this was 98, just shy of or just over 20 years ago. Well, there's a lot of ice back in 2000. There we go. Now let's see what happens over the last 20 years, my friends. All right, so we're back in 1990. So it didn't go all the way into 2020, but you could see over those years, let's go towards the end here, that the ice gets a little bit smaller and smaller. So this is 2011, 12, and it's getting smaller, 13. Isn't that crazy? So let's talk about that. Let's think about that for a moment. So as our ice is melting, it's causing that conveyor belt to move a little bit differently. So we're going to take a break. We're going to let you all think about this, think about those questions you asked, and think about how our oceans and our climate are, playing hand in hand. As our oceans are warming, as our Earth is warming, our conveyor belt is moving faster. How is that going to change things? All right, my friends. So it looks like we're getting a couple questions coming in. Gonna give it another minute, see if any more pop up. And then we're gonna wrap it up here in the studio. All right, everyone. So we're going to answer these couple questions that we have, and then we're going to wrap up by kind of talking about the last few things that influence our climate and our oceans, and then about what we can do as individuals to maybe make some changes. So Janelle wanted to know, are Nemo and Dory really friends in real life? That's a great question, Janelle. So Nemo and Dory are a clownfish and a blue pallet tang, and they do both live in tropical regions. Now, whether or not they're hanging out and traversing across the waters, who knows? But here is an example of a clownfish. You can see that they live inside this anemone, which is a beautiful invertebrate. They don't have a backbone, right? And the fish call it home. And then I think we have a picture of a blue pallet tang, right? There we go. There's Dory. And so these fish, like, in fact, actually, I think they're in the same exhibit here at the aquarium. You can see the clownfish in the background. So they do live in similar habitats, similar temperatures, right? As since we're talking so much about our ocean temperatures. But like I said, I don't know if they have a grand adventure. Now, Mr. Gutierrez wants to know, do the melting icebergs affect the temperature at all? And do they affect the movement of the water? Yeah, so if you recall this one, right, we watched how the ice was expanding and melting. Now, this is mostly important for a couple of things. When the water is kind of drawn up in ice, it lowers our sea surface temperatures. Now, as all that ice melts, all of a sudden there's a lot more water, and we're going to see that sea surface rise. However, as far as the temperature goes, as the ice melts, it becomes cold water, and it's really, really cold because it's just on the verge of melting versus freezing, right? And it's really, really cold, so it starts to sink. Now, as the ices melt faster, water starts to sink a little bit faster, which can then kind of speed up that conveyor belt or that heart pumping that I was talking about earlier. And so it can have a lot of effects. Now, we've talked a little bit about our temperatures and all of that, but how is that all connected, right? So as the water is warming, it also deals with precipitation and things, right? So it talks about our cold water, it melts, it goes to the tropics, it's evaporated, it moves through clouds, and so it's all connected. The ocean drives our climate. Now, Cynthia, we're actually going to be wrapping it up with questions in here, if that's okay. I know there's a couple coming in right now. But the last thing I want to touch on is how we can change that. So the biggest thing driving our changing climate, of course, the ocean drives our climate, but we are driving the changing aspect. And it's all due to those burning fossil fuels. And so instead, I want you to think about what we can do to maybe limit our actions and our effects on the ocean. How can we reduce energy use? What do you think? Yeah, so turning our lights off, I know that's such a simple one, but the more things that are burning and using energy, the higher our energy use goes up. So it's simple things like that you can do every day. I know one person turning their lights off might not make a huge difference, but if we all sitting here watching take that note and start to make those changes, it doesn't take one person doing everything perfectly, but an entire planet doing it imperfectly, right? We're trying to make steps in the right direction. Can you think of anything else that you can do? Something that simple, right? Looking and learning about renewable energy. For us, I know for me in particular, right? It's so easy to just say, oh, my energy comes out of the plug when I turn it on, right? But where does it start? I want you to learn a little bit more about that and think about that as you go through your daily lives. Now, friends, we are wrapping it up in the studio, but thank you for joining us today. I hope you learned a little bit about how our temperatures and our surface temperatures can really play a part in moving our nutrients and our climate around our globe. If you have questions, I encourage you to continue the discussions. Otherwise, have a wonderful Tuesday, almost afternoon. Bye, everyone. Thank you.